A 45-minute commute? That's way too long. I'd love a way to see where all the traffic is throughout the day. We can use the HyperLogLog to create a solution. HyperLogLogs are all about efficient counting. We can count unique visits to a website, daily clicks from users on a specific advertisement, even track traffic, all while preserving privacy. Let's see how we can use a HyperLogLog to power a traffic heat map for the city of San Francisco. Hop on in, let's go for a ride. A HyperLogLog is a data structure that answers a simple question. What's the approximate size or cardinality of a set? That's it. HyperLogLogs optimize for space or memory over perfect accuracy. So you use them when you're counting really large sets and you don't need or have the space for perfectly accurate counts. If you need more set-like functionality or perfect count accuracy, then you should use a Redis set instead. But remember that when counting large sets, a Redis set will use a lot more memory than a HyperLogLog. With only 2 key commands, it's easy to master HyperLogLogs. We'll add elements to the HyperLogLog with the PFADD command. We'll fetch the cardinality of one or more HyperLogLogs using the PFCOUNT command. To create our traffic heat map of San Francisco, we'll create a HyperLogLog for each major intersection in the city. To count the vehicles, we'll add the license plate numbers scanned at each intersection to that intersection's HyperLogLog. When we render our traffic map, we'll use the cardinality estimate for each intersection to show how busy it is. The higher the cardinality, the hotter the intersection. Let's imagine we're at the corner of Market and 10th in San Francisco. We'll refer to Market Street by the ID 12, and we'll refer to 10th Street by the ID 27. To record a license plate in the HyperLogLog, we'll use the PFADD command, like so. PFADD count :SF:12:27 and our license plate number. I'll add 60 more license plate numbers to our HyperLogLog to further our example. Now, I want to point out something with this traffic counting system. A HyperLogLog maintains a count of unique members. So if a car pulls a U-turn in an intersection and gets scanned twice, the HyperLogLog will count it only once. This means our count might not always perfectly reflect the San Francisco driver's unique driving habits. Also, a quick word about privacy. Like most people, San Franciscans value their privacy. No one really wants us tracking their movements around the city. What's interesting about the HyperLogLog is that it naturally helps to preserve privacy. Once we put a license plate into a HyperLogLog, we can't get it out. A HyperLogLog stores as little information as possible to estimate its counts. This means that HyperLogLogs are a great way to count unique members without explicitly storing personal data. Now that we are recording vehicle movements around San Francisco, we need a way to get each HyperLogLog's estimate of the traffic at each intersection. We run the PFCOUNT command to get a HyperLogLog's count. To check our Market and 10th Street HyperLogLog, we call PFCOUNT count:SF:12:27. 61 is returned. To keep our heat map up to date, we'll call the PFCOUNT periodically in all of our intersections. What if we need to zoom out on our heat map to see a coarser-grained view at a neighborhood level? To do that, we'll need to consider data stored in several HyperLogLogs. PFCOUNT lets us do that too. When we pass multiple HyperLogLog keys to PFCOUNT, we get a count representing the cardinality of the union of those HyperLogLogs. Our command would be PFCOUNT followed by our intersection keys. This will give us an approximation of the number of distinct vehicles moving around a larger area on our map. Yeesh, don't go to Civic Center during lunch hour. Our example records vehicles at each intersection, but we never specify in what time frame or how long we keep that HyperLogLog. A sliding window method of recording HyperLogLogs with key expiry would be one solution. We'll leave that exercise to the viewer, but if you'd like to see a similar approach to sliding window data, check out our 2-part explainer videos on Redis sets. Okay, review time. We've learned how to add elements to a HyperLogLog with PFADD. And we've learned how to get the cardinality of one or more HyperLogLogs with PFCOUNT. What will you do with the Redis HyperLogLog? HyperLogLogs are ideal for tracking IP addresses to estimate unique visitors to a website, user check-ins at locations, and monitoring any large set of elements where approximating cardinality is the main focus. To learn more about Redis HyperLogLogs and other data structures, sign up for our free online courses at Redis University, our online learning platform for all things Redis. Thanks for taking a ride with me around Redis HyperLogLogs. Hope to see you again soon, and make sure to look both ways before you PF count.